All right, so here it says Kerry earned a total of $900 last year on his investments. If $7,000 was invested at a certain rate of return and $9,000 was invested in a fund with a rate that was 2% higher, find the two rates of interest. All right, so let's let X, because we have to find the two rates of interest, let's let X equal, and we'll say it's the percent for the $7,000. Okay. And then we'll say y is equal to the percent for the 9,000. All right. And so what do we know about this? Well, we know that the second rate was 2% higher. So then what we can say is y is equal to our x plus, now remember, have to convert that to decimal form, 0. I'll get it right here soon, 0.02. Okay. And so that would be our percent there. And so now what we need to do is we need to get our other equation. So the other equation is going to be 7,000 times x plus 9,000 times y, and that's going to give us 900. So we'll have 7,000x plus 9,000y equals 900. Now, this one's set up perfectly for substitution already. So what I'm going to do is I'm going to substitute that in here. So I'm going to take that whole thing and substitute it in there. So what that gives me 7,000x plus 9,000 times x plus 0.02, and that equals 900. Now I'm going to have to distribute here. So I have 7,000x plus 9,000x plus 2 times that's going to be 18. So that'll be 180 because we'll have 0.02 times 9,000. So that'd be 0.0018. Move it over 2 decimals, and it's 180. And so then 900. So minus 180. All right, so we have 14, 15, 16,000 x equals. Now we have to borrow. That's going to be an 8. That's going to be a 9. Oh, that's actually not needing over there. That's still a 10. And so we'll have 10 minus 8. It's going to be 0. That's going to be a 2. And that's going to be a 7. All right. So now we need to divide by 16,000. Now here's a chance where we know a calculator might actually be quicker than doing it by hand. So let's look and see how we would do it on a calculator. We're going to take 720 divided by 16,000. So we'll take 720 divided by 16, 1, 2, 3. And so we get 0.045. Now remember, that's the decimal form of the percent. And so we get 0.045, which gives us 4.5%. Okay. Now, if that's what this is, then y is equal to 0.045 plus 0.02. And so that's going to give us, well, I guess we could put equals first, and then we'll put the arrow to the percent itself. So that's going to equal 0.0, and that's a 65, which is 6.5%. Okay. And 4.5% is for 7,000, and this is for 9,000. Okay. So now we got to test. Y is x plus 0.02. Well, again, we have to convert it back into the decimal, so that's why we're going to leave it with our decimal forms here. So 0.045 plus 0.02 is 0.065. The first one checks. What about the second one? Well, now we're going to take 7,000 times x. X was 0.045. We should have wrote it the other way around first. 0.045 times 7,000. 1, 2, 3, and then that's 7 times 5 is 35. That's 28, 29, 30, 31. And then we moved it 3 decimal places, so it'll be here. And then we had the 0.065 times 9,000. 1, 2, 3, that's 45. It's 54, 55, 56, 57, 58. and move it 3 decimal places. So now we have 585 plus 315. And so 5 and 5 is 10, 8 and 2 is 10, 5 and 4 is 9, $900, and that's what it's supposed to equal. So both of them work, and so those are our correct percents for those amount of dollars to get the final value of $900 interest investing at those two amounts. All right, if Dakota has 4 times as many quarters as dimes, and they have a combined value of 770 cents, how many of each coin does he have? Well, let's say X is equal to the number of dimes. Well, then 4 times that, 4X, is equal to the number of quarters. Now this one, we could do a couple different ways, because really what we're going to have is, this is actually going to be y, okay? So in a two equation system, we would actually call this y. And then what we would say is we'd have to do the conversion like we've been doing. But in this one, it really sets up so nicely with one equation or one variable here. Okay, so that's kind of a nice thing. We can do it with two, but because the way it's written, I'm going to just use this variable. I'm not going to put it in as y. Okay. And so what does that mean? Well, they have a combined value of 770 cents. All right, so, well, now I'm going to have the number of amount for dimes is 10 cents. Amount for this is 25 cents. So maybe let's erase that y so we don't get ourselves confused. And so it's 25 cents. So we have 10 times x plus 25 times 4x equals, and that's going to be equal 770. Okay, so really what we would have done is it would have been y is going to be this one, and so then y is going to be equal to 4x, and so then we could substitute the 4x here, and that's really what we did. And so but we don't know how many total coins there were here. That's kind of the key thing. So we would just have y equals 4x, and that's x, and so then we could substitute it in here. And now what we're going to have is 10x plus, so that's going to be 100x equals 770. Well, that's 110x equals 770. Well, if we divide by 110, x is equal to 7. And if x is equal to 7, if we plug that back into our equation, y is equal to 4 times that, which is 28. So there's 7 dimes, 28 quarters. Okay, so that's going to be our total. Now, does 4 times that equal 28? Yeah, so that equation works. And so how about this one? Does 10 times 7 plus 25 times 28 equal 770? Well, that's going to be 70. And so 28 and then 25. So that's going to be multiplied. So that's a 40. That's 14. That's 16. That's 4, 5, 0, 10. And that's going to be 5, 6, 7. 700 plus 70 is 770. So that does appear to be the correct value. So again, technically I probably should have said, well, okay, well, this is equal to just a y. And then over here, I would have said, well, y equals 4x. And so that would have been how I would have got that one. And then I could have plugged in the y here, and that would have worked my way down. But I think it's a little more intuitive if we just kind of plug it in here, and then we just have that one variable and that one equation. All right, let's pause there and we'll come back for more.